Hello, my name is Andrew Geary and welcome to Seismic Sound Off, in-depth conversations in applied geophysics. In this episode, I speak with Don Paul, Executive Director of the USC Energy Institute, Professor of Engineering, and holds the William K. Keck Chair of Energy Resources. Dr. Paul had a distinguished 33-year career with the Chevron Corporation, retiring as Vice President and Chief Technology Officer. He currently serves as a senior advisor at the Center for Strategic and International Studies in Washington, D.C., and is appointed by the U.S. Secretary of Energy to serve as an academic representative to the National Petroleum Council. In this episode, we discuss intelligent energy, the boom and bust nature of the industry, energy careers, and much more. Our conversation next. So Don, you are the Executive Director of the USC Energy Institute. You are working on an area called intelligent energy. Could you explain this concept and some of the programs you are working on?
Sure, I'd be happy to, and good morning, everyone. Intelligent energy, or smart oil fields, smart grids, the basic concept is the growing and continuous intersection of digital technology with an operating energy system or an operating infrastructure. So in our particular application here at USC, we focus on really two infrastructures. One is oil and gas, and the other is power grid. And then in the technical areas associated with that are emerging areas such as informatics and cybersecurity. Just as some background, I think most people in the industry are aware that the emergence of so-called digital oil fields, smart oil fields, is now really about 20 years old, started about 20 years ago. So we're really into what I call the next generation, or smart oil field 2.0. And that's really a big focus of what we're doing at the Energy Institute.
Building off some of the things you said there, how does things like informatics, big data, you say sometimes the Internet of Things, how does that relate to the industry and its future?
Well, historically, and I think it's important, and certainly geophysicists as a profession understand this, that the oil and gas industry has really been a leader in the application of information technology computing to an industry. And in the upstream, geophysics and reservoir simulation have been advancing along the curve of computing basically since the advent of digital computers. And I think that's one of the strengths of geophysics, and it's actually one of the particular contributions, I think, that geophysicists make to the industry as a whole beyond the specific technical application of seismic geophysics, for example. And the use of information technology in the downstream was one of the first applications of digital control and automation systems. So there's a long history in oil and gas, and we continue to be, deeply connected to the advancement of information technology. What's different about what I would call the informatics or big data and analytics paradigm that's emerging across all industry, not just the oil and gas industry, of course, is two things. One, it's advancing on the broad front of sensing, communications, computing, automation, control that's cutting across all industries. And so it's natural that it would be absorbed into the oil and gas industry. And the implications of this are a broadening of the set of data that's involved, particularly the big data analytics, which collects both structured data like seismic data and production data, but also lots of unstructured data, and begins to look for ways to understand correlations, optimization, prediction of, for example, operations, predictive maintenance, which is a practice that's been going on quite a while, and other areas is really, I think, coming to the oil field operations as an example. The industrial Internet of Things, the industrial version of IoT, is a particular construction, particular architecture around this, and is being advanced on many fronts. Many companies are looking at this. Its early applications in oil and gas are going to tend to be the production operations part of the system. Perfect example are things like adding intelligence and automation and control to pump-off controllers and to other parts of the operating infrastructure. To some extent, the surface operations is a natural because it looks like other industrial types of applications in other industries, manufacturing type applications. But nonetheless, you add more sensors, you have better communications, more computing, you can add intelligence to the devices themselves. They can basically interact with other devices without having to go through a traditional central control room. That's something that's going on. We expect to see that advance. And the driver behind it is avoided events, that is unplanned downtime, optimization, picking up small efficiencies in the system that eventually accumulate and make a difference. Something that's common in the downstream in the oil and gas business, but I think is now really coming up into the oil and gas business in the upstream. But also, ultimately, it's a way to reduce costs. It's a way to operate more efficiently from an energy point of view, from a HES point of view, emissions control, and so on and so forth, predictive maintenance. All of those are kind of natural extensions into oil and gas operations.
You had a distinguished 33-year career with Chevron, retiring as vice president and chief technology officer. So you offer a lot of expertise in these things that you are talking about. Do you think this type of career arc that you had, 33 years with one company, is feasible to hope for by today's geoscientists?
Well, that's a very good question, and I have that conversation frequently with my students. I guess my perspective on it is yes and no. When I entered the industry back in the 70s, this was the common model, certainly for the integrated majors, but even some of the larger service companies. Today, I think it still is the model substantively for the global majors, and certainly in national oil companies, which I think is important to keep in mind too, because many of my students are international students and in fact are already working for national oil companies. So will there be a piece of the business that has a career employment model, if we want to use that term? And I think the answer is yes, and for very good reasons. When you're involved in programs, projects, assets that last not years, not just decades, but generations, it's useful. In fact, I would argue it's extremely valuable to have people that actually have experience in those areas or that particular asset that's decades long, because there still is a very important experience component in the oil and gas business. Now, what has changed, I think, is that the number of organizations that have a model like that for good reason, where they have big projects, for example, that might last, the project itself could last 10 years. So how do you do projects that last 10 years if you have rapid employee turnover? That's a real challenge. You have to have some core. On the other hand, the broader base of the industry, I think you're not going to see these long-term employment structures. You'll have a more fluid where people move as companies change, companies come and go, new companies emerge. We've certainly seen that happen in the shale play, for example, which has a much shorter cycle time than the traditional oil and gas business. So is there a career employment option in the oil and gas industry? And I would say yes, there is. And the global majors and the national oil companies continue, I think, to have that as a primary model for the core employees. Now, having said that, I think we are seeing a shift to where the core pool of employees, even in those companies, is perhaps doesn't extend to everybody that does work for the company like it used to. Now, when I started with Chevron, we had our own seismic crews, for example. We did everything ourselves. That, from a business perspective, that model has changed, and so that pool of career employees is a smaller percentage of the total workforce. And that's not uncommon in some other industries, too. One of my colleagues here at USC, who came to USC after he finished his career, much as I did, was the chief technology officer for Northrop Grumman. And we used to discuss this. And the aerospace business has the same model. That is, there's a core of employees that you want to work for the company their entire career. But many projects, on a project basis or programmatic basis, you obviously have to add additional suppliers or potentially have people that you hire that don't necessarily stay on with the company. So is there a career employment? Yes. Is it universal like it used to be? No.
As someone working and studying this industry for decades, what is your perspective on the boom and bust cycle of oil and gas that could lead to some of these layoffs?
Well, booms and busts, first, I think it's important to realize that booms and busts are intrinsic to natural resource industries. Oil and gas, of course, but minerals are the same way. To some extent, real estate is the same way. And this has been going on in the oil and gas business since Drake's Well in the 19th century. And what's interesting about it is that they have the same fundamentals apply. And whether it was the great bust of the 1920s, which lasted until the 1970s, lasted almost 50 years, or the 80s, or this recent one, they all have the same drivers in the sense that typically they're driven by a new large resource base has been added. In the case of the most recent one, it was the shale resource. And with that, and with as fueled by high prices because of either concerns for depletions in the current resource base or some other factor, high prices stimulate overdevelopment of that new resource. Ultimately, the supply overwhelms the demand and down come the prices. And the intrinsic issue is you always overinvest. And that means you put too much capital into the system. You move further down the drilling queue, for example, in the upstream business, you're now drilling prospects you wouldn't drill at lower prices. So you're setting up a higher cost structure in the industry. The other thing you do is you hire, and sometimes frenetically because you're so busy. So you're building in the problem you're going to have to solve when you have the bust, which is you now have to reset the cost floor. And so inevitably that does many things. And in the upstream, as we've seen in the recent one, it means you reduce the staff, you restructure the supply agreements with suppliers, and of course they end up in the same situation of having to shrink their asset base and their employment base, and the cycle starts over. We keep hoping that somehow you'll learn that lesson and not repeat it again, but it's almost intrinsic in the system. Anybody that comes to work in the oil and gas business has to expect that there will be booms and busts. And I tell all the students that this is not something that's going away. There is never a perpetual boom. I think it's something that you learn when you live live through it. I've lived through 4 of them. So, I think that it's part of the industry.
Given the technology changes the industry is seeing, and you mentioned that you'd been through 4 of these cycles, I read reports and articles saying that even if the boom or when the boom happens again, the oil industry might look different still because of these technology changes and the efficiencies gains.
Yeah, and that's a really good question. And it's certainly, in other words, that there's been a restructuring of the industry and a potentially a secular change in this process. And booms and busts from the point of view of prices, right? There was going to be price volatility in the oil business. That's an inevitable. How one responds to it by either rapid expansion, in fact, overexpansion of employment and investment, which is what we did prior to the last downturn, whether we don't respond that way. And I think the most interesting thing that I am hearing when we talk to my colleagues in the industry, whether operators, service companies, or technology companies, is a perspective that we can't, in other words, when prices recover, we can't grow back. In other words, we can't rebuild the size of the staffs that we had before the last crash. We can't overinvest capital like we did the last time. Can we substitute information? And can we engineer smarter oil and gas operations? That gets back to the smart oil field in such a way that we can maintain our cost structure that we had to rediscover in the bust. That's the other thing that happens. As you go, whenever you have the bust, people rediscover that cost matters. And so can you think about a structuring of the industry built on advancing information technology, the so-called digital transformation of the oil industry? Can we do that, and will that allow us to basically hold the line on costs and therefore not have the kind of tumultuous restructuring restructuring that takes place when we've overexpanded and then have to correct in the bust. So is there a view that that can be done? I think so. And so one of the first things people would think about is, can I automate? Can I substitute information so that I reduce the risk on capital decisions, but secondly, operate more efficiently, operate with fewer people so that I don't have to build back up as I raise activity level. So can you raise productivity? Ultimately is what you're talking about. Barrels produced per worker. And I think there's a view that the answer is yes to that. And therefore, I think that's a pathway that a lot of companies are on. This is something, by the way, that the downstream part of the oil and gas business has been doing for a long time, in part because I like to say the upstream, traditionally, historically, the upstream business, the E&P business, is built for the booms. The downstream has been built for the bus. And they've always maintained a cost discipline and structure and continuously try to raise productivity and efficiency in those systems. And when they get into a period where they have much better margins for a while, because they happen to catch that right swing between falling crude prices and product prices, and they get a little bump in their margins, it doesn't change the way they operate. They don't all of a sudden go out and spend more money. So whereas in the upstream in the booms, you want to raise your volume of production, so drill more wells. So I think this perspective is coming into play.
What kind of role do you tell your students that you see geophysicists might take in the industry of the future?
Well, geophysics is a core set of observations in the E&P business. So that, to my mind, that's not going to change. Now, as the business has shifted, for example, recently into a big chunk of the capital investment going into the particularly the U.S. shale play, that the role of geophysics in the shale play, geophysics has had to adapt itself to a different operating model. The nature of the shale business, and the shale business has changed lots of parts of the business, not just geophysics. It's changed the way we look at drilling. We look at drilling as more of a repeatable manufacturing type activity. It's driven by numbers, driven by the sheer numbers of wells. It's driven by the short cycle times. You're on site and then off site in a month. And the shale business is driving the whole system, along with some of these other technical things like the Internet of Things and more automation, is driving the system to more of a real-time perspective. So one of the challenges for geophysics is how do we adapt this very central set of observations about the subsurface that come from geophysics to a world that operates differently like they do in the shale, where the subsurface knowledge you need to have is associated either with not just the natural state, but the actual state that's induced by your hydraulic fracturing. So you've seen the onset of microseismic. So I expect geophysics to continue to adapt itself to the changes in the business and the changes in that the technology enables. And we've always learned to adapt ourselves to faster and faster computers. I anticipate that all of those things will take place. A question I get, which I don't know that I really know the answer to, is for example, today, because of the computing infrastructure, a single geophysicist can do way, way more than they could 20 years ago. So is the pool of people that will be employed in geophysics in the industry growing or shrinking or staying the same? I would expect that, as we have seen over time, that in the direct area of geophysics, certainly the pool of geophysicists is probably not going to grow. On the other hand, and I've pointed this out several times to people, and in my experience, geophysicists contribute in the oil and gas industries in ways beyond the technical field of geophysics. In Chevron, many of the key contributors, both technical and managerial, in the broader information technology area, were geophysicists. CIOs were geophysicists. Information architects were geophysicists. For good reason, because geophysics always lived at the interface of digital technology and the industry. And that interface, the interface of digital technology in the industry, is not going away by any means. In fact, that's an area that's growing.
You have been involved in a lot of extracurricular activities, appointments. How did you find these type of activities and appointments for your career? And did you find one particularly the most valuable of all those?
Well, I don't know if there's one. I think that, first off, I think being involved in communities, whatever the goal of that community group is always worthwhile. Personally, it's extremely important to the industry because the industry needs people that are involved in the larger community so that people see oil and gas as not only what they read about in the papers, but is actually populated by intelligent, caring, and thoughtful people. But I would say that I've been involved extensively for a long time when I was at Chevron with the educational process, because ultimately, well, of course, we could see 20 years ago this big demographic shift, which is now nearly complete, big crew change it was called, coming. And so there's a clear imperative in the industry to support, interact with, guide, advise, and ultimately hire out of the university system in earth science and engineering. So I've always enjoyed that engagement and have been involved in that. In the CTO role, well, actually really began when I was president of Chevron Canada. I began on a business basis to be involved directly with governments and regulatory agencies. And I found that very valuable because it gives perspective. And that was continued on as CTO and my involvement with a lot of involvement with the Department of Energy, Department of Homeland Security, Department of Interior, and as well as state agencies. And I think one of the things that's important about that is to recognize that by the very nature of the industry and its impacts on where it operates and the communities, that more than many industries, you need to be aware that there is a social license to operate for the oil and gas business. That in many cases we exist because societies not only expect us to do things that they need, produce energy, but also to do it in such a way that the secondary effects are not detrimental. And by interacting with governments and regulators, I learned to understand where they're coming from, understanding their role. And that, I think lets you come to those agreements that allow us to do our business, but also allow them to fulfill their social and political obligations.
This is my last question for you. RigZone performed a survey asking respondents to describe their sentiment for the industry in 2018. 38% described their sentiment as hopeful, while 30% were concerned about the industry going forward. What would you say?
Oh, I'm very positive about the industry. I mean, you look at one, I think the new waves of technology that always wash over the industry and renew it in some ways. And there's a big jump in that going on. We talked about it earlier. I think this wave of digital oil field 2.0 or the industrial Internet of Things for oil and gas, or however you want to describe it, that's all very positive. I think it creates new career opportunities for people in the industry. It creates opportunities for people to come into the industry with different skills and perspectives. So I'm quite positive about that. I think pricing has, in my view, appears to have stabilized in the $60 to $70 range. I think that almost all aspects of the business can function well in that, as well as keeping all the ultimate product prices in a range that consumers can live with as well. So people get energy they can afford, they get it reliably. That is the goal of the industry, after all. Sometimes in the upstream, we forget that, if we have sky-high prices, somebody's paying for that down the line. And ultimately, there has a correction. But I think we're in a range there on prices. So that means the cash flows are back. I think the opportunities to take the emerging technology and build in a sustainable cost floor. And the technology, as it always has, is creating new resource development opportunities. So I view all of those as very positive. Does it mean there aren't challenges? Yes, there are always challenges, but I don't see them as being substantively different than we've always had to face. But bottom line, I would definitely be on the optimistic side. Now, from the point of view, are we going to go back to the hiring booms that we had in the boom? I don't think so. So there is an implication there in terms of making sure And I tell students that it is going to be competitive, but there are going to be opportunities, and to think about opportunities that may be even a little more diverse than a traditional career pathway. Taking your talents and your content knowledge and blending them with into these new technology arenas.
Is there anything I should have asked you that I did not?
I think that you brought it up a little bit, but I think it's important that I think everybody in the industry, whether they're in the industry, an operator, the service company, techco, academia, I think we have to do a better job of creating excitement in STEM students about what you can do in the oil and gas industry and the kind of things that go on. You tend to hear from some students, it's an old industry. It's been around a long time, no question about that. Will be around a long time. That's the nature of natural resource industries. But I think the opportunities for, and we've seen this in the Smart Oilfield program here at USC, which, by the way, has been going on now since 2003. It's been a long time. And students come into the program from traditional engineering, geoscience. They also come in from computer science, cinematic arts, visualization type activities. Almost everybody comes in and sees the problems and sees the kind of things that go on and gets out to the field and sees what it's really like. Almost all of them are excited to stay in the industry. So I think we can do a better job on the recruiting end of recruiting. What I mean is engaging young talent that's interested in science and technology and engineering, that the industry is a good place to work.
Well, that's a good place to leave it for our listeners. I appreciate your time and for thinking hard on these important questions.
Well, I've enjoyed it very much, and have a good day.
SCG is taking its annual meeting to Anaheim, California this year, where the exhibition hall and technical program will focus on big data, the Internet of Things, and many of the topics Dr. Paul discussed. Visit scg.org/am to learn more and register to attend. If you enjoy this show, please leave us a 5-star review on Apple Podcasts. Your reviews bring a smile to our faces. Follow Seismic Sound Off at scg.org/podcast to hear new episodes. Seismic Sound Off is sponsored by the SCG Wiki, the place to find hundreds of biographies of geoscientists, open access tutorials, and ongoing translations of SCG's best-selling book, Robert Sherritt's Encyclopedic Dictionary. Type wiki.scg.org into your browser to visit the world's first online geophysics encyclopedia. Original music by Zach Bridges. This episode was hosted, edited, and produced by me, Andrew Geary. Special thanks to the SCG podcast team, Jennifer Crockett, Allie McGinnis, Mick Sweeney, and Adrian White. Thank you for listening. This is Seismic Sound Off, signaling off.